All right, in our previous videos, we have talked about a lot of trig equations, but there are some styles that we have not yet addressed. So this is going to be the last one, and I'm going to show you some that require some factoring, maybe some identities, and you should be pretty well equipped to solve any trig equation after this one. All right, so number one, tangent times secant equals tangent. And what I want you to realize, it's a big no-no that everybody wants to try, and that is canceling out on both sides of the equation. Um, so the theme of this question is don't cancel entire trig functions. What people will want to do is say divide each side by tangent. Secant x equals 1. Secant x is 1 when secant goes with cosine, when cosine is 1, and cosine is 1 at 0 and 360, and so 360n. So here's the problem with that. Why no canceling? Why is that wrong? It seems legit. What about this equation? If I said, what are the values of x that make this true? It would be tempting to divide both sides by x and get x equals 4. So is that wrong? Well, not exactly, because 4 does make it true. However, 0 also makes it true. Would you agree? So what you need to do instead is subtract 4x from both sides, make it 0, factor out an x, and get either 0 or 4. So why no canceling? Well, if you do that, you can eliminate certain answers. So instead, what we should do, this is a no-no, we'll see how it's half right, just like it was half right in my other example. I'm going to move the tangent over, make it 0. Okay, the multiplication property of 0 is very powerful. If you can get stuff that's multiplied together, which usually happens by factoring, and that stuff equals 0, then you just set all of your parts equal to 0. Okay, so I factor out a tangent, and now I have two parts. Just like over here, when I took each part and set it equal to 0, I'm going to do that here. Tan x is 0. And secant x minus 1 equals 0, which means secant x must equal 1. So secant x equals 1 at 360n. We already had that, but the neglected answers are when tangent equals 0. So tangent is sine over cosine, so we also need to know when sine is 0. Because tangent will be 0 when sine is 0. So where does that happen? Sine is 0 at anytime we are at kind of ground level. So that's 180 degrees in. So basically, if you cancel, you get this spot. If you factor the way we should, you get both spots. So our final answer is 180 in. All of those answers, all of these answers are included in those answers anyway, so we'll just call it 180 in. So the theme of that one, don't cancel from both sides. Move it over and factor. All right, the next style that's pretty typical. This looks like a quadratic. All right, we've factored stuff in the form of a quadratic before. That was usually like x to the 4th and then x squared and then constant. Another typical trig equation is a quadratic equation, but with trig functions instead of x's. Okay, if I gave you 2x squared minus 5x plus 2 and asked you to solve for x, you would factor it if it would. If not, you'd use the quadratic formula. So let's see if this one can factor. Let's see, 2x and x. It's like if I go minus 2 minus 2, there is, no, that's not going to do it. Oh, there's my mistake. I needed to go minus, let's see, minus 2 minus 1. So I get negative 4x negative 5x. Okay, so it'd be 2x minus 1 times x minus 2. I'm going to do the same thing here, but instead of x's, I have cosine x's. It's no big deal. 2 cosine x minus 1 times cosine x minus 2. So if you factor the exact same way, if you were to FOIL that back out, check and see that we would get the original yellow expression. Now, again, the multiplication property, if you have things multiplied together that equal 0, if any of those parts equals 0, you get a true statement. So on the left, if I move the 1 over and divide by 2, I get where is cosine 1/2. Works out nicely, a good non-calc question. Over here, I get cosine x equals 2. Now, just because I have two parts doesn't mean each part necessarily leads me to a correct answer. Where does cosine equal 2? Well, hopefully by this point, you know that cosine is never 2. Cosine lives between minus 1 and 1. But over on the left, we get where does cosine equal 1/2. All right, cosine is a half here and here. So depending on the wording of your question, if it is find all answers between 0 and 2 pi, that would be our answer. So you have to watch the directions to see which answers, whether they're in radians or degrees, and whether they want just certain answers or all of them. But that's one possible way to answer that. All right, the answers are not going to change. The two locations are the same here and here. It's just which form do we want to give our answer. Okay, lastly, sine squared plus sine minus 1. All right, and this one, I should have it equal to 0. It's going to put us in the same dilemma that we get in when we solve quadratics. We try to factor it. If it doesn't factor, we use the quadratic formula. So this would be like factoring x squared plus x minus 1. So we would need to find two factors of negative 1 that add up to positive 1. So negative 1 is either plus 1 minus 1, minus 1 plus 1. That's not going to work. Basically, this is a prime quadratic. So what do we do in quadratic equations when it won't factor? Well, we use the quadratic formula. Except this time, instead of x equals, I get sine x equals. Okay, so it's negative b. All right, this is plus 1, negative 1 for a, b, and c. Negative b plus or minus square root of b squared minus 4 times 1 times negative 1 all over 2. All right, so I get sine x must equal negative 1 plus or minus the square root of 5 over 2. Okay, so my trig function is isolated. So negative 1 plus square root of 5 over 2 is this, and I need to inverse sine that number. All right, and I get 0.67. This should be in radians, to make sure radians. So I get 0.67 radians. And again, based on the directions, we'll decide where we want, which answers we want to give. Let's just go plus 2 pi n for now. And there's also the negative 1 minus the square root of 5. It's another solution to this quadratic equation. Negative 1 minus square root 5. Make sure you hit enter before you divide by 2. I get negative 1.62. Okay, so we kind of deal with it the way we did before. It's just when you get those answers, you inverse sine them to figure out where the sine x is that number, not just x being that number. And then we'll look at our directions and see, I'm assuming the directions say we're in radians. Let's assume that the question was your domain is radians from 0 to 2 pi. Well, here's one answer, 0.67. if I add 2 pi or subtract 2 pi from that number, I'm outside of the domain. Over here, negative 1.62 is not in the domain, so I need to add 2 pi in to that value, and it ends up being 2.475. All right, excuse me, I found a mistake. What I forgot to do over here was inverse sine that second option. Okay, and what happens is, if you look at that, inverse sine, I was trying to take an inverse sine of a number outside of minus 1 to 1. So if you do negative 1 minus square root of 5 divided by 2, I get negative 1.6. So then if I try to inverse sine that, I get an error because there is no time when the sine equals that value. Okay, so learn through my mistake. This one is not an option. So where does my other answer come from? Well, my other answer over here, when I inverse signed and got 0.67, go back to my calculator, at negative 1 plus square root of 5 divided by 2. Try it again. Negative 1 plus square root 5 divided by 2. And then inverse sine of that value. So there's my 0.67 radians. There's another place that has a sine of 0.618. So back to the unit circle. Nope. What I was asking my calculator is, where does the sine equal 0.618? Where's my height 0.618? And that happens somewhere over here, which is 0.67 radians, and also somewhere over here, which is going to be 180 minus 0.67 radians, or pi minus 0.67 radians, 2.09 radians. All right, so again, sorry for the mix-up. Learn from my mistake. Our two answers are, all right, I found another one, full of them this time. What I needed to do was pi minus 0.67. Finally, 2.47. Made a mess of this one, sorry. 2.47. All right, so hopefully that wasn't too messed up for you to follow. Let me just kind of go through this last one again. If it's quadratic form and it won't factor, use the quadratic formula. When you get your two answers to the quadratic formula, inverse sign those two answers. Both of those answers might produce two possibilities. In this case, one of the two answers didn't give me any value, so that one's out. The other answer, because the quadratic formula gives two answers, gave me two possibilities. And if you eliminate all your calculator typos that I made, you're able to get to 0.67 and 2.47. And once again, these are solutions to the equation. So plug them back in and make sure that it's right. All right, so I said at the beginning we were waiting for a challenge. Evidently we got it because I made a mess of it. So forgive me. It's Friday, video over. I'm out.